We're going to talk a little bit about RayOne EMV lens and the optics and how it works and why it works. So it's a Graham Barrett design, which is it's amazing. We know all his work. But if you look at this design, it's that really perfect amount that you have that small amount of positive spherical aberration. And as you can see here, right, so when you talk about spherical aberration, the light rays in the periphery, they're over-refractive, and that will create this extended range of vision. Right, so, and it's very small, we don't need much because the cornea has positive spherical aberration. And that was the concept. And here is bench data, right, showing us, the MTF curves, and it's exactly what we see clinically. You correct for spherical aberration, you have that perfect distance focal point, but just that perfect amount, is if you look at the depth of focus curves, it can extend the depth of focus curves.
Quick question. So
sure.
If you're targeting, a patient, some lenses we're used to sort of targeting maybe a little bit myopic or a little bit hyperopic or right on target. Where would you say the perfect target if you're going to miss? Do you go right on plano, first plus, first minus with this platform? I'm just curious how.
Yeah, I think again, if you look at the DOF curve,
yes.
has that broader range, and it means what we call the TRE, the tolerance to refractive error.
Yes.
Right? If you end up a little bit plus, a little bit minus, we're still within. It keeps that distance vision. But I think for the patients, they enjoy a little bit better near.
Okay.
I would say plano or first minus.
Okay.
Right?
Great.
I think for the dominant eye, I always start with plano. You really want to hit the target. You want to make sure the patient has good distance vision. And then you can blend a little bit.
Sure.
So that's that slide right there. So
perfect.
Great question.
Yeah.
Because again, if you have plano in both eyes, we know the patients, they can get good intermediate vision with this lens. And with both eyes together, it's what we call binocular summation. When you're checking vision with both eyes, patients, they usually can read one line better. Right? So if you offset one eye just a little bit with this platform, even minus 0.5, patients, they really achieve a really great functional vision.
Great. Thank you.
Yeah, no, great question. But I would say, plano or just the first minus, because they can still keep the distance vision and you can extend the range of vision. So this is our study. Again, we look at the EMV platform, and we want to do all the in vivo measurements, right? So we knew the bench data from Graham Barrett, and we looked at refractive outcomes. We performed in vivo wavefront analysis, and we also were very curious to look at automated refraction. How we're measuring this eyes post-op. So that was a prospective study. We included 42 eyes, and we looked at all the refractive measurements, uncorrected visual acuity, distance-corrected visual acuity, the distance-corrected intermediate, the distance-corrected near visual acuity, and we looked at high-order aberrations and manifest refraction compared to a lot of different wavefront machines. So I think Bill was showing, the surgery and comment the stability of the lens. The centration, it's amazing, right? So it's very stable there. I think that it's really good for refractive lens position, very well centered. You see how the optics covers that entire area. So really, we're not concerned about decentration. So with, in terms of distance visual acuity, the uncorrected visual acuity was 0.06, the mean was 0.06 logMAR, that the mean was basically 20/20, right? And all eyes achieved 20/25 or better. I think this is when we start seeing the differences here compared to the different, all the other monofocal IOLs. But this was really impressive when we look at distance-corrected intermediate visual acuity. 85% had 20/40 J3 or better. So really, now we have one monofocal lens that gives that really good functional vision, right? I never tell the patients glasses free, and of course this is a monofocal lens, right? But I tell them, you will need glasses. You will need glasses for your computer, for your tablets, and then when you see these patients post-op, they say, oh doctor, you told me that I needed glasses all the time, and I'm doing great. I can see my phone, I can see my tablet. The numbers were impressive. It was the same for the distance-corrected near visual acuity. It was 78%, 20/40 J3 or better. So the intermediate was at 66 centimeters. The near was at 40 centimeters. And this is really interesting, just to understand what we did here. We had our manifest refraction, right? So this was our baseline. And then we looked at the eye trace refraction, Hartmann-Shack refraction, and the Pentacan wave refraction. And this is so important because all the automated, all the autorefractors, they give us some myopic results. And then when I saw that, I was like, oh, this makes sense because we know that with spherical aberration, right? So you see that myopic shift. So it's just important to teach your staff and your technicians that, if you out refracting those patients, don't trust that number there, right? Because you're basically measuring the spherical aberration, right? So you really need to push plus. It's almost like half diopters. With some devices, it was close to 1. The difference, 0.75, right? Or if a patient needs like refractive enhancement, we want to make sure you do a really good manifest refraction. It's almost like that the patient is accommodating. You're just measuring all that EDOF component of the lens, the spherical aberration, right? Is that depth of focus. That shows me that broad DOF curve. And we're really curious to see, okay, so this is lens, the bench is telling me the lens has positive spherical aberration. So what are we seeing in vivo? And this is the Pentacan wave, this is Scheinflug, Hartmann-Shack Scheinflug device. And we know spherical aberration is pupil dependent, but for a 4.5 millimeter pupil, that spherical aberration was very small, was 0.12, 0.13, very small. That perfect amount of spherical aberration that you keep your good quality distance vision and you can have that slightly extended range of vision. That's what we found. So, but in conclusion here, right, in vivo wavefront measurements of the EMV shows that small amounts of SA and the patients can benefit from functional vision at intermediate and near. So we had really great results for distance-corrected intermediate and distance-corrected near. And the automated refraction tends to be more myopic, about 0.5 diopters, right, compared to your manifest refraction. Thank you very much.